Here's another example of finding a power function. I chose one with fractions in case it's slightly more complicated, um, but it's still the same process. So we have find a possible power function for f of 1 equals 3 halves and f of 2 equals 3 eighths. So same directions. Take those, identify your x and y values. So we'll have, 1, 3 halves is our first point, and 2, 3 eighths is our second xy point. We'll take and we'll plug those values into two separate power functions, which again is y equals k times x to the p. So we have 3 halves equals k times 1 to the p, and 3 eighths equals k times 2 to the p. All right, so step 3, set up your two ratios, making sure that the way you pull the left and right side of the equations correspond to each other. So I'm going to put k times 2 to the p on the top and k times 1 to the p on the bottom. So that makes me put 3 eighths over 3 halves. Cancel my k's, combine 2 divided by 1, which is just 2. So I have 2 to a power. When I do 3 eighths divided by 3 halves, remember you can take 3 eighths and multiply the reciprocal of 2/3. So that actually cancels really nicely into 1/4. So then you're like, okay, well, what power of 2 would give me 1/4? I can get the 4 if I square 2, but the fact that it's in the denominator is going to indicate to me that the squaring needs to occur in the denominator. That would give me 1/4. So my power on the 2 value here to begin with needs to be -2. If I have 2 to the -2, that's the same as 1 over 2 to a +2 using exponent properties, and that will give me the 1/4 that I needed. So our power is -2. So we take that, plug it back into either formula that you like. I'll use the first one. 3 halves equals k times 1 to the -2 power. Find k. So 3 halves equals k. 1 to the -2 power is still 1, and you get that k is the constant of 3 halves. So your answer is the power function 3 halves x to the -2.